4G LTE absolutely changed the game for how we use our phones. It gave us the high-speed internet that, let's be honest, we can't live without today. But have you ever actually wondered how it all works? Like, what's happening behind the screen? Well, today, we're going to dive in and unpack all of it.
Seriously, just think about it for a second. The way a video can stream instantly, or a map can load in a new city, how does that even happen? It kind of feels like magic, right? But it's not magic. It's an incredibly well-designed system, and we're about to pull back the curtain on its architecture. And here's the best part. Even though it sounds super complex, the entire 4G network really boils down to two main parts. That's it. Just two. Once you get a handle on what these two halves do, everything else just clicks into place.
Okay, so let's start with that big picture view. What are these two core pillars that hold up the entire 4G world? Here they are, the EUTRAN and the EPC. Now think of the EUTRAN as the front line. It's the part that your phone is actually talking to wirelessly. And then you've got the EPC, which stands for the Evolved Packet Core. This is the network's brain, the powerful central system that does all the real heavy lifting behind the scenes. So let's zoom in on that first part, the EUTRAN, or the Radio Access Network. This is the piece of the puzzle that we're all interacting with every single day, probably without even thinking about it. And the star of this radio network is something called the eNode B. Now, that's a technical name, but it's really just the official term for a 4G base station, what you and I would call a cell tower. It's the first, most important link in the whole chain, connecting your phone to the network, right through the air. But an eNode B is way more than just a big antenna. It's a busy piece of equipment. It's juggling radio signals, it's scheduling data for thousands of people at once, it's allocating resources so everyone gets a fair shot, and maybe most importantly, it handles handovers. That's the secret sauce that keeps your call or your stream from dropping when you're driving down the highway. So how does it pull off those amazing 4G speeds we all love? Well, it uses a few key technologies, like OFDM and MIMO. You don't need to know all the deep science, but here's a cool way to think about MIMO. It's like using multiple antennas to send and receive data at the exact same time. It basically turns a single-lane road into a massive, multi-lane superhighway for your data. Okay, so our phone is connected to the tower. What happens next? Well, we move from the airwaves into the digital core of the network, the Evolved Packet Core, or EPC. This is where all the real intelligence is. First up in the EPC, you've got the MME, which is the Mobility Management Entity. The easiest way to picture the MME is as the network's gatekeeper. It's the bouncer at the door. It checks your ID, makes sure you're allowed to be on the network, and it keeps track of where you are so it knows where to send your calls and data. It's all about signaling and control. Right, so once the MME says you're good to go, your data starts to flow through the SGW, the serving gateway. Think of this as a very smart local router. It's the anchor point for your session, and it directs all the data packets flowing back and forth between you and the cell tower. But of course, your data needs to get out to the real world, right? That's the job of the PGW, or the Packet Data Network Gateway. This is the main exit. It's the final bridge connecting your carrier's private network to the huge global internet. Every single YouTube video you watch, every website you visit, it all goes through a PGW. And you might be wondering, how does the network know all this stuff about me? That is where the HSS comes in, the Home Subscriber Server. This is basically a giant, secure database that holds the master file on you, what your plan is, what services you have, your security details. It's the network's ultimate source of truth for every single subscriber. So this brings us to a really smart part of 4G's design. It separates traffic into two lanes. You have the control plane, which is managed by the MME. This is all the signaling and management stuff, the who are you and where are you going. Then you have the user plane, managed by the SGW and PGW, which is just for your actual data, your videos, your messages, all of it. This separation is a huge deal for efficiency. It means your data can fly through a path that's optimized for pure speed. All right, we've met the whole team, we know who does what. So now let's put it all together. Let's follow one little packet of data on its journey from your phone all the way out to the internet. So you tap a link. Instantly, that request is beamed from your phone to the closest eNode B. The eNode B then zips that packet over to your serving gateway, the SGW. From there, the SGW routes it to the main packet gateway, the PGW. And finally, boom, the PGW sends your packet out onto the public internet. It's this four-step dance that happens in a fraction of a second, over and over again. And the reason this whole dance works so beautifully is because of a truly revolutionary idea at the heart of 4G. It is an all-IP network. What that means is that everything, a website, a video, even a phone call, is chopped up and treated as tiny packets of internet data. Now, why should you care about that? Because that all-IP architecture is the direct reason we have the mobile experience we do today. It's what makes those super crisp voice calls with VoLTE possible. It's what allows for smooth video streaming while you're on the bus. It's the very foundation that almost every single modern app on your phone is built on. 4G was a massive leap forward, there's no doubt about it. But, technology never stops moving. So let's finish up by looking at where 4G started to show its age and how it paved the way for what came next. As amazing as it is, the 4G architecture just wasn't built for everything the future had in mind. Its latency, that's its response time, was just a little too slow for things that need instant feedback, like self-driving cars. It also wasn't designed to handle billions of tiny Internet of Things devices all trying to connect. And its design was kind of rigid, built on specialized hardware. You can really see the evolution right here. The names change, sure. The eNode B becomes a GNB, and the EPC becomes the 5G core. But the real game changer is the architecture itself. It goes from being semi-flexible to being cloud native. That basically means the network becomes software. It can be changed and upgraded with code, like an app, instead of needing all new physical boxes. That flexibility, plus that huge drop in latency, is really the magic of 5G. So when you look back, the big takeaway is this. We can't underestimate 4G. It wasn't just another small step up. Its architecture literally built the foundation for the entire mobile-first world that we all live, work, and play in today. And that's really the core of it all. The 4G network is this brilliant combination of the radio part, the EUTRN, and the smarts of the core network, the EPC. And together, they created the fast, reliable, all-IP system that truly put the internet in all of our pockets. If you think about it, the architecture of 4G allowed us to build this incredible skyscraper of the modern mobile app world. So that leaves us with one last really exciting question. With the even more powerful and flexible architecture of 5G, what entirely new world are we about to build next?